Hello viewers, in today's session we are going to discuss an important and conceptual problem from definite integrals. And here we have to consider this integral, that is 0 to pi by 3 square root of 1 minus cos 8 theta d theta. And we'll solve this integral with the concept of absolute value function. So let us take this integral as I, right? And let us start with some concepts from trigonometry. Now see, from the double angle formula, we know that cos of 2x is given by 1 minus 2 sine square x. So this is the double angle formula for cosine function in terms of sine function, right? Now here we have cos of 8 theta, right? So here what we will do, will replace x by 4 theta. So when we replace x by 4 theta, we'll get cos, here we get 2 times 4 theta, and here we have 1 minus 2 sine square 4 theta. Now here we have cos 8, this is 8 theta, and here we have 1 minus 2 sine square 4 theta. Now taking this term to the left hand side and cosine 8 theta to the right hand side, we have 2 sine square 4 theta is equal to 1 minus cos 8 theta, right? So the first step is to replace 1 minus cos 8 theta by 2 sine square 4 theta. So we have I 0 to pi by 3, and here we have square root of 2 sine square 4 theta, and here we have d theta. Now here we can take square root of 2 outside the integral. So we have square root of 2, and here we have 0 to pi by 3, and square root of sine square 4 theta d theta. So now here we cannot cancel this square with this square root, right? Because we cannot write here sine square 4 theta raised to half, and then we can cancel out this 2 with this 2, right? So we cannot do this process over here, because this is a definite integral, and moreover the sine function, the sign of sine function, it varies in different quadrants, right? So we cannot here cancel out this 2 with this 2. So what we will do here, will make use of the definition or the concept of mod function. So now let us see the definition of mod function. Now see, mod of p is defined as square root of p square, and this is equal to a positive p whenever p is greater than 0, and mod of p is 0 whenever p is equal to 0, and mod of p is negative p whenever p is less than 0. Now here we have square root of sine square 4 theta. So let us assume p is equal to sine 4 theta. So here we have square root of p square, because here we have sine square 4 theta. So square root of sine square 4 theta can be written as the absolute value of sine 4 theta. So the second step is to replace this square root of sine square 4 theta with mod of sine 4 theta. So now we have here square root of 2, and the limits are from 0 to pi by 3, and here we have mod of sine 4 theta, and here we have d theta, right? So the first step was to make use of the double angle formula for the cosine function. The second step is to express the square root of sine square 4 theta as mod of sine 4 theta due to this definition of mod function, right? Now let us take the third step. So now in the third step, we'll make use of the method of substitution, right? So integration by substitution method can be used here. So we'll take here t is equal to 4 theta. So we'll assume 4 theta is equal to t. So we have dt over d theta is equal to 4 times the derivative of theta with respect to theta. So this is 4 times 1, that is 4. So we have d theta is equal to dt over 4, right? Now let us change the limits accordingly. So here theta varies from 0 to pi by 3. So when we have theta is equal to 0, then the value of t is 4 times 0, that is 0. And when theta is pi by 3, which is the upper limit, so here we have t is equal to 4 times pi by 3, that is 4 pi by 3, right? So now let us rewrite this integral in terms of t. So now we can write the integral I as square root of 2, and the limits of integration now varies from 0 to 4 pi by 3, and here we have mod of sine t, and d theta is replaced by dt over 4, right? So now we can take this 4 outside the integral. So we have here square root of 2, 0 to 4 pi by 3 mod of sine t dt, and here we have 4. So now we have to evaluate this integral. So now in the next step, we have to evaluate this integral. And before evaluating this integral, let us see the sign convention for the sine function here, because here we have mod of sine t. So let us draw the quadrants here. So we have first quadrant, this is second, this is third, and this is fourth. Here we have 0, and here we have pi by 2, this is pi, this is 3 pi by 2, and here we have 2 pi, right? And here the limits of integration vary from 0 to 4 pi by 3, that is t is equal to 0 to t is equal to 4 pi by 3, and let us write 4 pi by 3 as pi plus pi by 3. So it implies that this upper limit, that is 4 pi by 3, it falls in the third quadrant, because here we have pi, and we have an additional angle, that is pi by 3, right? So we have this angle, that is 4 pi by 3. So this angle is 4 pi by 3. So now the sign convention of trigonometric function in the 4 quadrants, it says that in the first quadrant the sign function is positive. In the second quadrant the sign function is also positive, and in the third and fourth quadrant the sign function is negative, right? So this concept of the sign convention in 4 quadrants is of prime importance while solving this integral. So now with the help of the definition of mod function, we can now write mod of sine t is equal to positive sine t when t belongs to the first or second quadrant, and we can write this fact as when t belongs to the interval that is 0 to pi, right? So when we are in the first or the second quadrant, the sine function is positive, so mod of sine t is positive sine t when t goes from 0 to pi, and mod of sine t is negative sine t whenever t belongs to the third or the fourth quadrant, that is from pi to 2 pi, right? So when we go from 0 to 4 pi by 3, it means in the first and second quadrant the sine function is positive, and in the third quadrant the sine function is negative. So we have to split the limit at this point pi, because here the sine function is changing sign from positive to negative, right? So now we can write this integral as a square root of 2 over 4, and now we can express this integral as a sum of two integrals, right? And we'll split the limit at this point, that is pi. So we'll write 0 to pi, then we have mod of sine t dt, and here we have pi to 4 pi by 3, and here we have mod of sine t and dt, right? So now we have to find out the values of these two integrals. So now in the first integral, a mod of sine t can be replaced by positive sine t, because t varies from 0 to pi, right? So here a mod of sine t can be replaced by plus sine t, and in the second integral the limits vary from pi to 4 pi by 3, right? From pi to 4 pi by 3, it means we are in the third quadrant, right? So in the third quadrant the sine function is negative, so mod of sine t must be replaced by negative sine t. So now this integral I is equal to square root of 2 over 4, and here we have 0 to pi, then we have plus sine t dt, and here we have pi to 4 pi by 3, and here we have minus sine t dt. So now we have two simple integrals, and here the integral of sine theta d theta is equal to negative of cos theta. So here we have minus cosine t, and limits are from 0 to pi, and here we have the negative sign, so we can take this negative sign outside the integral, and the integral of sine t is minus cos t, and limits are from pi to 4 pi by 3. So now we can write square root of 2 over 4, and here we can take negative sign outside, and then we can substitute the limits and we'll take the difference. So we have cos pi minus cos of 0, and here this negative and this negative, when multiplied together it becomes positive, and substituting the limits and taking the difference, we have cos 4 pi by 3 minus cos of pi, and now we can write square root of 2 over 4, and here cos pi is minus 1, cos 0 is 1, so we have minus 1 minus 1, and cos 4 pi by 3 can be easily calculated by splitting 4 pi by 3 as pi plus pi by 3. So we have cos pi plus pi by 3, and cos pi plus theta is the negative of cos theta. So we have minus cos pi by 3, and that is cos 60 degrees, and this is half, so we have minus half. So here we have minus half, and here cos pi is minus 1, right? Okay, so now we can solve this expression. So here minus 1 is minus 2, and here we have minus half plus 1, and this is square root of 2 over 4. This is plus 2, and 1 minus half is simply half. So now we can write the value of the integral I as the square root of 2 over 4, and here we have 2 plus half, that is 4 plus 1 over 2, that is root 2 over 4 times 5 by 2. So this is 5 root 2 divided by 8, right? So viewers, the value of this integral is equal to 5 times square root of 2 divided by 8.